Hello student, let's try to understand the principal focus and focal length of concave lens. A concave lens has two surfaces, hence it also has two principal focus. Now, the first principal focus of concave lens is virtual position of a point object on the principal axis of the lens, for which the image formed by the concave lens is at infinity. First principal focus of concave lens represented by f1. The rays falling on concave lens tend to converge to f1 on the principal axis of concave lens before actually meeting f1. These rays are intercepted by concave lens, which refracts them into beam parallel to the principal axis of concave lens. They would form image at infinity. Thus, f1 is virtual position of the point object whose image would be formed at infinity. The distance of first principal focus of lens from optical center C of the lens is called first principal focal length of concave lens. It is represented by f1. Now, formation of image by convex lens. A convex lens forms the image of an object placed in front of it at any point on the object at point source, from which an infinity number of rays start. These rays suffer refraction on passing through the lens. We can locate the position of the image, the size of image, by converging any two of the following three spatial rays. These path of the rays and the refraction of the lens known given. Rays incident on the lens is direction parallel to the principal axis of convex lens. The refraction of this rays passes through second principal focus at the lens located at other side of the lens. So it is passing to the principal focus. Second, if passing to the optical center, it will go undeviated. If it is passing to the f1, then it will become parallel after refraction. So a ray passing through the optical center of the convex lens passes straight after refraction through the ray passing through the first principal focus of the convex lens incident on the lens become parallel to the principal axis of the lens after diffraction through the lens. The image is formed at point where any two of the refracted rays actually meet for real image or appear to meet for virtual image. The position, size and nature of the image depends upon the position of the object in front of the lens following 6 cases. When object is at infinity. When object is at infinity, large distance from the lens, which is several times the focal length of the lens, we say that the object is at infinity. Suppose the object consists of an arrow AB pointing towards. It is not shown in figure 4.45 because its distance is too large. Ray starting from the top point A of the object diverge, but on traveling such a large distance are assumed to become parallel. While falling on the lens, we have shown two parallel AC/DC object which incline to the principal axis of the lens. So here the object is getting formed, students. Student, you see the ray AC passing through the optical center goes undeviated and ray AD converges on the refraction through the convex lens. The two refracted rays meet A, which would be real image of the top point A of the object. Draw A dash B dash perpendicular to principal axis of the lens. This is the real and inverted image of the object AB, which is formed at second principal focus of the lens. Hence, conclude that when object is infinity, the image at second principal focus of the lens, real inverted, highly diminished, image much smaller than the object. So this is what the answer. Let us try to understand case second, student. When object is held beyond 2f1. So if the object is beyond 2f1, student, then what it is going to happen? Then object will be formed before 2f2. Here the distance of the object is more than the twice of the focal length.